Okay, so this is day 10 of the first distance learning packet from BCSD and the math section. Okay, so we're starting off with a task, and it says that there are two people. They have summer jobs, putting stuff in envelopes, and they make different amounts. All right, so the first part is to draw a graph, which we will do on this side, and then write equations that show their earnings. And the second part, who will earn more, and we look at the graph also to show. So that's going to come up as a different slope. All right, so let's get started. So we have a graph. We're going to put both of their information on the same graph. So I'm just going to start this off with my X and Y axes. This is X. This is Y. And it said Y is the amount that they earn. So earnings as Y. And the number of envelopes stuffed is N. Or we're going to say that's X. Okay, so anytime we have money, it's going to be on the Y-axis. So this is earnings. Earnings. And that's in dollars. And this is going to be the number of envelopes. Okay. All right, and then we need some information for each of these people. Okay, so Anna she gets $14 for every 400 envelopes she finishes. Okay, so $14 for every 400. So first of all, what do we think she will make if she does 0? I would say she would make $0. So this is a proportional relationship. So then we need the x-axis to go to at least 400. But perhaps more, but let's see if we can fit 400 on there. So number of envelopes, let's see if we can get up to 400. If I count by 10, I don't think it's going to work. So what do we need for Jason? He goes up to 300. Okay, so let's count by maybe 20s, 25s. Let's go by 20s. 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, 260, 280, 300, 320, 340, 360, 380, and 400. That works. Again, we're just trying to use up as much of the graph as possible so our data, our lines aren't scrunched into the corner where it's difficult to see. Okay, and then earnings, just $14. So we don't have to go up by very much. Maybe I'll skip and do those as 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so that's enough. All right, so let's first graph Anna, and let's do her graph in green. And we know there's a point at 14 and 400. So 400 comma 14. So 400, find 400 on the x-axis, follow it up to where it meets. So be careful. Where does it meet? 14. Okay, so there's a point right there. Okay, so again, we decided that if she does nothing, she makes no money. So it's going to start off at 0, 0 at the origin, and it's going to pass through that point right there. Okay, so again, just the line extends on forever. I mean, until she's done with her job. So it can go past our point. So hers looks like that. And then let's do Jason's. So I'm going to just mark hers. Actually, let's go ahead and label that. So this is Anna, okay. And then let's do Jason's in orange. All right, and he gets $9 for every 300 envelopes. So 9 and 300. So 300 is here. Follow it up, and then we put a point where it meets the 9. Okay, so basically I'm just looking at the y-axis and I'm visualizing that line. So that's where our point is. Again, if he doesn't work, he also gets nothing, so that's proportional. Okay, so there's Jason's graph. All right, so let's just look at this. So based off of the lines, so steeper slope would indicate more money per envelope because it's a rate. Money is y, envelopes is x. So our rate, our slope is y over x, change in y over change in x, so dollars over envelopes, so money per envelope. So hers is steeper, so she will get more money. And if we look at, so Jason's, we put a point at 300 envelopes. So he only makes $9 at 300 envelopes. What would Anna make? So her point's about there. So if we come over about $10.50 for the same number of envelopes. So yeah, she's making more money. Okay. Now it says to write equations. Okay, so we need rates. So I'm going to do Anna's here and then Jason over here. Okay, so Anna makes $14 for every envelope. So we need to make a rate. So this dollars per, dollars is our slope, dollars per envelopes. Okay, and we're just going to divide it, so we'll get a decimal. So 14 divided by 400 is 0.035. And that's dollars per envelope. Okay, so that's just 3.5 cents per envelope. Okay, so Jason, he gets $9 for every 300. And if we divide that, we get 0.03. So what did we say before based off of the graph? Anna makes more, right? So let's see if that is confirmed. So she makes 3.5 cents per envelope, and Jason makes 3 cents, or 3.0 cents per envelope. So Anna's equation, let's just put that in green. So y equals mx 0.035x. And there's no y-intercept because they both go through the origin. Okay, and then Jason's equation, y equals 0.03x. Okay, so that's it for the first one. Let's see. B, who makes more from stuffing the same number of envelopes? How can you tell this from the graph? So that's exactly what we did. That's the points right here. So we just took 300 envelopes. Jason makes $9, which was given to us. And then we just kind of followed it up to Anna's graph to see how much she would make. And that point is about right there. It's not perfect, but it's very, very close. And then if we follow it over, she makes $10.50 because it's halfway between 10 and 11. So Anna makes more. So Anna makes more money from, so just use the same wording right here, from stuffing the same number of envelopes. Then how can you tell this from the graph? We could just say her slope is greater. So that would basically kind of push her amount. So imagine this point, and as her slope increases, it just keeps going up and up and up and up, and equating to more and more money. Okay, the last one. Suppose Anna has savings of $100 at the beginning of the summer, and she saves all her earnings from her job. Graph her savings as a function of the number of envelopes she stuffed. How does this graph compare to the previous ones? Okay, so she's still making the same amount for her job, but she started off with 100. So what is that going to do? That's just going to add a y-intercept. And then the question is, okay, we have to compare the graphs, but then what is the meaning of the slope So we can answer that one. So the slope is the amount she earns per, that's our keyword for slope, per envelope. Okay, so that's that one. And then how does this graph compare? So we're going to compare the graphs. So this is with a savings. So she started off with $100 savings. And if we look at our y-axis, we don't have 100. So we have this little trick. We can put a squiggle like this. It just says we skipped a bunch of numbers. And I'm going to put 100 there. I'm going to start my graph. And then I'm going to draw a line. And the slope has to be the same as the previous. So it's really hard to see on this graph. But if we extended it, we could see, so the slope is going to be the same. Okay, it's going to be parallel to the green line that we drew before. It's just going to start at 100 this time instead of 0. So how does the graph compare? So the graph, the line, the slope is the same, but the line moved up to 100, which is the y-intercept. Okay, so there's a lot going on in that one. And again, because the numbers and the graph that we made, it just wasn't easy to see the difference. But again, we can use Desmos. We can graph these two equations, right? We can graph that equation. We can graph Jason's equation. And the new equation for Anna will be y equals, same slope. We already said that. And then we just have plus 100. So you can graph that. You can see what the difference is. Okay, let's continue. So we have rule of 4. And again, I'm going to help you with the equation, but you can make a table based off of the equation or the information that we're given here in the description. Okay, so it says you have $10 and will save $5 a week. How many weeks will it take to have a total of $50? Okay, so we started off with 10. You have $10. So that's our starting point. That's our initial value. That's what we also call the y-intercept. So that's a 10. And then we will save $5 a week. A is the same as per. That's our rate. That's our slope. So that's 5. So our equation, again, we start off with mx plus b. We just substitute those numbers in. M is 5. And then b is 10, positive 10. Okay, so the question is, how many weeks will it take to have a total of $50? So $50, that's going to be our y value. So how many weeks? Weeks is x. So we're going to use our equation and see if we can solve it for x if we know that y is 50. So just substitute 50 instead of y, and I'm going to write everything else the same. Okay, we're solving for x. So we're going to subtract 10 on both sides. And we're going to get 40, oops, oh, that's fine, equals 5x. And then we're going to divide both sides by 5. And we will get 8 equals x. So then the answer is 8 weeks. How many weeks will it take? It'll take her 8 weeks. Okay, so just also mentally, so without doing all the algebra work, the equation, if you want to get to 50, you already have 10. So you really need just $40 more. You're making 5 a week. So 40 divided by 5 is 8. I mean, that's exactly what we did solving this equation, but you can confirm it mentally as well. Okay, so again, make a table. And to make a table, you could just choose any values for, I'm not going to do this for you. I know I said I wouldn't. So X is weeks. Y is savings. Okay, and just choose a number. Again, just whatever you want for X. You could 0, 1, 2, 3. And then you're going to put those numbers right here in this equation. So if I put a 0 there, 5 times 0 is 0, plus 10 is 10. If I put a 1 there, 5 times 1 is 5, 5 plus 10 is 15. Okay, and then you can continue it from there. Okay, so here is just a practice of substituting values and then carrying out the operations following our order of operations. Some have exponents, which we've done, and some are just multiplication, division, or fractions. And it's just calculator work. So let's choose one that's maybe a little messy. So I'm going to choose this one. So I'm going to rewrite it, but I'm going to use all the values that we are given at the top. So I'm going to write the fraction like this. Okay, multiplication. So pi is 3.14. Actually, I'm going to use parentheses for multiplication. R, so r squared, so 12 squared, which we should know is 144. And then times h, which is 10. Okay, so this is actually the volume of a cone. Okay, so we're just going to multiply this out with a calculator. So you have calculators on your phones. And what I would do is I would multiply the top. So 3.14 times 12 times 12. Or you could do 12 squared, but my calculator, I'm just doing this on my phone as well, just so I know that you can do it with yours. So 12 times 12 instead of 12 squared. And then times 10. Okay, so what does that equal? And then at the end, divide by 3. So we get 1,507.2. And it says to round to the nearest tenth. Okay, so if you want me to show you again how that looks, okay, so 3.14 times 12 times 12 times 10, okay, and then divide by 3. Okay, so that's how we get that. All right, and then the others, just remember order of operations. So this next one, do the parentheses first and then multiply. Do the exponent first. It's basically like the one we just did. At the bottom, make sure exponents go first. And that's it. Okay, and then one more of these. So I've actually had some questions on like how do we write a story. So the story is just like a word problem. So you can actually go back and take a look at these rule of fours, and this is the story right here. That's all you have to do. Okay, so let me solve this first. So I'm just going to rewrite it. 5 and then parentheses x plus 3 and then equals 170. Okay, so using distributive property, 5 times x is 5x, and then 5 times 3 is 15, equals 170. Okay, and then we're solving for x, so let's get rid of all the numbers on the same side as x, so let's subtract 15. So 170 minus 15 is 155. And that on the left is 5x. Okay, the 15 minus 15, that became 0. So we have 5x equals 155. Divide both sides by 5. We get x equals, let's see, 5 and 31. Okay, so there's our solution. So writing a story. Okay. Think of it like this. I'm going to look at this second step here. Oops. Okay, this step right here. Okay, because all this is a linear equation. So let's say I have y equals 5x plus 15. Okay, that's the same as that left side. And then I want to know y equals 170. So y equals 170. So let's use that example that we had in the rule of 4. So it doesn't matter what we say. So John has $15 and saved $5 per week. Okay, how many weeks will it take for John to get $170? And that's it. Okay, so the answer is 31 weeks. So that's what we did. We found the solution. So we create a story that has the same solution. Okay, it doesn't have to be based on this format right here. I mean, you could come up with something like this. You could, I mean, it's 5 times this, so you can have a rectangle and one dimension is 5, the other dimension is x plus 3, and the area is 170, so what is the length of the one side? Something like that. Okay, but don't overthink it. Just use information that you already have, change the numbers, and this is fine. Okay, so that's all for